Hello, everyone, and welcome to today's Minnesota Nursery and Landscape and Association webinar, Better Ways to Manage Japanese Beetles in Tree, Landscape, and Turf. At this point, it's my pleasure to introduce Dr. Verna Krischik, who is a tenured faculty in the Entomology Department of the College of Food, Agricultural, and Natural Resource Sciences at the University of Minnesota in St. Paul. Among her many responsibilities, she is the director of CUES, the Center for Sustainability Urban Ecosystems that promote natural resource management. Dr. Krischik, if you're ready, the floor is now yours.
Oh, thank you, Michael. And I saw the list of people, very familiar faces, so hi, Heidi and Tim and Mark, and hopefully we can talk in the question and answer part about any of your specific issues. So as you know, last year was a banner year for Japanese beetle. And the question on everybody's mind is why? Why are there so many? And here you see 5 slides, and we're going to talk about the different aspects of how Japanese beetle interacts with the landscape and new management techniques that have come about. So Japanese beetle in the center slide, that's a very common sight on roses, especially hybrid tea roses. And when they feed, they create damage, and that damage creates volatiles. And they are very sensitive to those odors. And they all fly in during the day to those damaged plant tissue. And they prefer to sit in the sun and have the heat of the sun help them digest faster. And then at night, they stop feeding, those volatiles stop being produced, and when it gets twilight, they fly off to turf to lay eggs. Now, it's not just the females. The males go with them, so they all leave. And so a common question is, if I have adults, am I going to have grubs? And the answer is no, and we're going to talk about that. If you look to the right, you see an adult. Those 5 tufts of white hair sticking out of the bottom of the elytra are the sign, and we're going to talk about some native species. On the left is a grub. They're C-shaped, and you see those big fossorial legs. We call them for digging. They lay on their back, and they scoot along on their back and grab the roots of the turf with those legs and stuff it in their mouth. And so when you look underneath at the grub damage, what you see is the turf dies. So if you want to look for grubs, you never look in the brown area. You have to look in the green area. They can move about 1 foot a day, and they do move through the soil profile. In the fall, they go deeper to overwinter, and then they come back out in the spring. And so we're going to talk about all this and then new information on how to manage them. So in summary, Japanese beetle is an exotic, which means it is here in the U.S. without its natural enemies. It isn't particular. It feeds on trees, shrubs, grasses, flowers. So we want to use the principles of IPM. IPM, the principles are always the same, but the pests are different. And I say that's idiosyncratic, that it is a lot of information about the life history of the pest that we have to know and the vulnerable stages to control it. And usually most insects are controlled in the larval stage, not the adult stage. But since Japanese beetle is such a persistent problem for about 6 weeks, in the summer we also control it in the adult stage. There's a lot of need out there from especially very pristine management locations like businesses or new housing developments that they really don't like the defoliation, so they want to control the beetle. And we're going to talk about different ways to do that. And we're going to talk about the life history of the Japanese beetle and related native species and why they've increased. So this is my roadmap for today's talk, and so hopefully it covers some of the things you've been interested. We've talked about Japanese beetle for a while. It's no longer a quarantine pest in Minnesota. That was lifted about 1990. The Department of Ag did a bunch of trapping. They found out that the adults start coming out of the turf around the 4th of July. Last year it was like a week earlier. On my website there's a really good bulletin that's updated on how to manage Japanese beetle with these new chemicals. So if you want to go read that, go to the website. It is still a quarantine pest in 11 western states. So if you're a nursery person in the greenhouse, and I know on the list there are a bunch of you all, you have to get if you're going to ship there, you have to get a phytosanitary certificate saying that the crop was raised according to the harmonization agreement or the protocol, which a lot of it is about not having grasses in the pots or grasses in with the plugs. And then if you do have Japanese beetle issues, then you have to use prophylactic treatment of the root ball of the soil. So you know better than other people if you're a nursery greenhouse person who's shipping interstate. There is also now a Japanese beetle program at airports in the Midwest because they have figured out that the Japanese beetle is getting spread. These airports have these runways, and between them there's all this grass. And so the grubs grow on the airports, and then they get sucked into the engine or sucked into the doors underneath, and the planes are moving them around. So now USDA APHIS, last 2 years, had also started a trapping program and pesticide program at airports. So Japanese beetle is unique among our scarabs in that it has this annual life cycle where it will go deeper in the soil and then comes out and defoliates the leaves of things, of anything green, really. There's 300 species. Now, I say it's unique because many of the white grubs, many of the other native beetles in this family that feed on the roots of potted plants or grasses, a lot of them don't feed as adults, so you don't know you have them. It's kind of incipient. You can see the grub stage is very clearly a scarab if it was the previous, if it's the picture we saw on the first slide. But it may not be a Japanese beetle, and so we're going to talk about how you identify the different species. But the life cycle is basically around July 4th. They come out, the adults come out, male and females. They go off to feed right away. These pheromones come off the plant. They aggregate on the top of things. The female lays about 60 to 100 of eggs for about 6 weeks, and by the middle of September, she's gone, and the grubs are feeding on the roots. So just look at this slide. The grubs are easiest to control in those first 2 months of August and September because they're little. As they get older, they get bigger, and they're much harder to kill. So we're going to learn about two new chemicals, a new pathogen out there that you apply in the spring, and everybody I talk to says they work really well for Japanese beetle. So the beetle first started in New Jersey, Pennsylvania. I've heard different things. Around 1916, 1917, it supposedly came in on potted plants, potted conifers from Japan. It was kind of funny this spring because Kyoto, Japan, a newspaper called me, and I gave them an interview because they were very interested why we in America were talking about Japanese beetles and what are Japanese beetles, because they don't have them in outbreak numbers in Japan. So just put that in your head and think about it. Why is it in the native range of this pest, they don't even know they have Japanese beetles when we're suffering here in the Midwest? So the dark green is where Japanese beetle is established. The lighter greens are where Japanese beetle is partially established. And then we have those 11 western states that still have a quarantine. So, again, identifying the adults is really easy. There are those white hairs. We call the damage skeletonizing just because they don't feed on the veins. They feed on the mesophyll, the plant material between the veins. So this is really quite clear on maple trees or on grapes, on grapevines. You see just the veins of the leaves left. And adults are active in Minnesota. Really, it says mid-June here. Really, from the end of June till end of August. They've switched over now to field crops like corn and soybean, grapes, apples. They're on everything. They're slowly moving north. I think they're up almost to St. Cloud already. And this is what you see with the adults. Here's some blueberries, and they have been a problem with blueberries for many years in Michigan, had a huge problem. And I had you-pick growers calling me trying to figure out how to get them off their fruits like blueberries and raspberries. so that the U-picks, when the people come, they won't be horrified by the Japanese beetles on the fruit. So it has become an issue. Over 300 different plants and 80 different plant families. One of their favorite food is linden trees. This is a picture from Kentucky, and that's 1 week. You see the 8th to the 18th, 10 days, and look how much foliage. Again, you just have the veins left. Now, one of the issues with the Japanese beetle treating linden trees, and again, for commercial buildings and for homeowners associations, they're the people that call me the most about treating. Japanese beetle won't kill the plant. It doesn't vector any diseases. And it's only out defoliating at the end of the summer where the plant has really fixed a lot of food already. So what it will do is slow plant growth down. And in urban environments, if you have a plant on a lawn or outside a building, you don't necessarily want them to get huge. So it's not the issue for it is for people like commodity growers, like grape, wine producers or table grape producers. But people still want to control these, and the problem with spraying a contact insecticide is people don't like to see you spray. So it gets us back to trunk injections and basal soil drenches, something like a neonicotinoid or azadirachtin or enamectin benzoate. And so those tools are available. The only issue is you're going to have is you want to apply it after the lindens flower. And with Japanese beetle, that's fine because it doesn't come out to August, and most lindens and basswoods are done flowering. But remember, it's going to be there the next year, so you will impact pollinators. And I have data, not the time to talk about it today, that shows that. So you will impact pollinators. People have been saying use dinotofurans safari as a trunk drench because it's so water-soluble, it's not there by the time lindens flower again. So maybe for those of you who are concerned about bees, and we all should be, instead of using imidacloprid, you should use dinotofuran safari. But imidacloprid will be in the flowers the next year at doses that will kill bees and any other beneficial insects. So that is an issue of concern when we talk about Japanese beetle. Some of the labels, the Bayer labels, say do not use imidacloprid on trees, on basswood or linden trees. Some labels don't say it, but the Bayer labels do say that. So here you see the adult and the grub, and Japanese beetle are the worst white grub. And again, this is partially because it's an exotic. So the reason why the Kyoto press was so excited about people in America talking about Japanese beetle and they don't have them there or they don't see them in really high numbers is when we have invasive insects come without their natural controls, they increase in numbers. Now, of course, you're going to say, wow, since 1917, nothing has figured out how to control Japanese beetle adults or grubs. And it's not quite true. In the East, where the infestations were high in the 50s and 60s, now you see very little Japanese beetle damage. And so there's a guy, a researcher at the Connecticut Ag Station called Dr. Andreades, and he went out back in the 70s trying to figure out this question, and what he found was in the soil there are these protozoans that attack Japanese beetles. And they take a while to increase in number, but they're there forever. They create epizootics, which mean they pass the organism, which is a protozoan, grows in the soil and stays in the soil. So it's not like a pesticide you apply and it disappears. And so it ends up in the East. There's these soil-inhabiting protozoans. One of the names is Ovicicula. And there's been research at Michigan, we're going to talk about in more detail, that you can release it and it takes a couple years, but it does control significant numbers of grubs. So that is a management tactic we're going to talk about again when we talk about biocontrol, but that is a pending good management for Minnesota. So I put together this table comparing the different scarabs. So the family Scarabaeidae are the dung beetles, and these are the beetles that you see in the Egyptian hieroglyphics that move the sun through the sky. And they got that identity because they wrap in Africa, Egypt, so the north part of Africa. Dung beetles are really common. There's very high diversity of them. And they take dung and they wrap it into balls and bury it. And the males and female push this ball kind of like the sun. So that's how this family is famous, the family Scarabaeidae. And all of them have grubs that live in the soil and then adults that feed on foliage, but many of the adults don't feed on foliage. So here is the ones we have in Minnesota. If I was giving this talk in Maryland, there'd be a second slide with the same number of other exotics that have been brought in. But we don't have those yet in Minnesota. But be aware, here we have 1, 2, 3, 4, 5, 6 species, but you'd have 12, 13 if you were talking about the East Coast. So the first one is the Japanese beetle. 1 year, the adults feed on foliage. The larval stage, which we call the grub stage, feeds on only the roots of grasses. The next one is the false Japanese beetle. It's iridescent, but it doesn't have those 5 tufts of white hair. The larval host is not known of these. They feed on similar plants, but maybe 1 to 1,000. 1 false Japanese beetle to 1,000 Japanese beetle. The next one is the rose chafer. It's a paler green, kind of a moss green, has longer legs. The host plant for the larvae are not known. I'm pretty sure it's birch trees in Minnesota. That's where they are attracted to Japanese beetle traps. And if I put them out near birch trees, I get a lot of rose chafers. Again, the adults and larvae feed. Masked chafers, this is a native pest in Minnesota. The adults do not feed, so you never see them. Photius, Atenius and Photius are our smallest species. They overwinter as adults in woodlot. The adults feed on manure. They don't feed on plants. It's just the grubs. And 7 Japanese beetles per square foot is the economic threshold. The economic threshold for these 2 tiny species are 50. And they're rarely controlled. I've had people on golf courses where they form mating balls twice a year in May and June, and they'll spray just a contact insecticide on the mating balls, but the root damage is rarely heard of. The next one is this Phylophaga, this large June beetle. Doesn't look like Japanese beetle, doesn't have those white tufts of hair. It's darker. It's attracted to light. So this is the only one of these 6 species that will show up at lights. It has a 3-year life cycle. It takes much longer. Instead of an annual, a 3-year cycle. It feeds on the roots of grasses, but the adults can feed on anything. They like cottonwood trees, roses. But again, in Minnesota, these native species, all these others on this list besides Japanese beetle, are native, and you never see them in the outbreak number because they're controlled by pathogens, soil microbes. So here's what a drawing of a grub. Every segment of the insect has those big white openings, and that's the spiracles, the breathing tube. They're always C-shaped. If you try to straighten them out, they die, they burst. Their body is in that C shape. They can flatten it a little bit when they lay on their backs and move. You see those really hefty legs for grabbing on the roots of grasses and stuffing them in their mouths, and those really hefty mandibles. But it's that end of the Japanese beetle or the end of the white grub that we use to identify them to species. So here's a drawing. You see the Japanese beetle has a straight line on its roster on that hind end, and then there's like a V-shaped suture. The masked chafer doesn't have that V-shaped suture. The next one is the May-June beetle, and instead of it V-shaped, the sutures are long and narrow. And then the turfgrass Photius and Atenius have these round sutures. So these are segments with hairs coming out of them on the roster, on the hind end of the grub, and that's how you'd know them to species. And why would you want to ever know this, right? Probably saying to yourself, Vera, why the heck do I need to know this? The only reason is if you have the native ones, you probably don't need to spend the money to apply an insecticide. Every time we use insecticides on turf or on a plant, you kill the good bugs, no matter how hard you try not to. And then you get pests which have no management, and you have worse problems. So it's always better not to spray a pesticide unless you really have a problem. And the first thing in IPM is to diagnose the appropriate pest. And so this slide is going to help you with grubs so that if you have some of these native species, it's probably not going to be an issue. And Japanese beetle grubs are usually found with a lot of dead turf. With these other species, I've been here in Minnesota 25 years. I have never heard them killing turf. And the adults do not do much damage to foliage. So back to our Japanese beetle again, and here's a close-up of that rasta and that V-shaped sutras. It's not just the half of the circle I'm talking about, that V-shaped sutra coming down. And here's another picture of its life cycle. I included this one because it shows you that pupa. And when I'm digging in my garden in June, this is what I come across. I don't come across a larvae. I come across that yellowish, brownish pupa. And the grubs in the fall, they go down deep in the soil, but in the spring they come up again, and then right by the roots you'll find this pupa. Now, having said that, these pupa are very vulnerable to raccoons or crows eating them or birds eating them, so there is natural control going on. And it's these stages that sit for a while that the pathogens are much better at controlling. I mean, they're good at controlling any life stage. But in the spring, when these larger grubs start coming back up from overwintering under the frost line, as they start coming back up, if we have a wet, cold spring where the temperature is below 50 degrees, then what happens is these microbes proliferate in the soil, and more pupae and adults are killed, and so it depresses the population. The reason we've had issues lately is the springs have been warmer. So you have to have wet, cold, 50 degrees. The beetles use up all their fat. The microbes work better, and you depress the populations. But we've been having warmer springs, and that is what is releasing Japanese beetle and why it's becoming a pest. So it really is a global change issue. So here is a picture of the May or June beetle. There's a smaller one and a larger one. Again, see this roster with the two long parallel lines. It has a 3-year life cycle rather than the annual life cycle. This is mass chafer. Why is it called mass chafer? It has, if you see a live specimen, there's little cheeks of brown on that second segment. Again, the adults don't feed, but here you see what the roster looks like, half a pie. And then this is the Aphodius natinius, the tiniest ones. That's what their roster looks like. Here's rose chafer. We don't have a picture of the roster. And here's false Japanese beetle. So now let's talk a little bit more about chemical control. I'm about halfway through my slides, halfway through the presentation. And so the standard for people has been to spray imidacloprid. For the quarantine for adults, it's Tallstar or Chlorofly Phos or imidacloprid or clothianidin on the root ball. For landscapes, for putting in the soil, it's imidacloprid or clothianidin or thiamethoxam. So the compounds here are what are traditionally used for grubs. And the reason why is you put them in the soil, the first three, and they get picked up by the roots, and they sit in the roots, and they're very good then at killing Japanese beetle and other grubs. The problem is that if you put them on turf, and there's clover in the turf, it gets into the flowers, and it kills the bees that are foraging. So it is an issue if you use a neonic, not if you have weed-free turf, but if you have any flowers growing in the turf, it is an issue. So all those neonics, if you go over to that third column, you see the LD50 is what kills 50% of the beetles. Those are the exact number. If you go over to the third column where I've interpreted it for you, those are all highly toxic. So most of what we have used for grubs in the soil are highly toxic to bees. They're not very toxic to humans. Chloropyrifos is, that was going to be withdrawn this year. It's no organophosphate, but the administration stopped the cancellation of it. It was used on homes. It's now used only in nursery golf courses. But all of those compounds are highly toxic to bees. So we have some new things out there that are working now. And when I say it's working, I'm getting information from my colleagues in the East. And there's a new chemical out there called acelepryn. It's by Dow. That's its trade name. And you apply acelepryn in May, and it gets into the soil, and it adheres to the roots of the plants. It's systemic, doesn't seem to get into the flowers, but it kills any of the grubs feeding on the roots. So it is a really good choice. You can buy it as a pesticide applicator. Homeowners can buy it in the product called GrubX. So you can buy it for grubs either as a professional product called acelepryn or in the consumer product called GrubX. Now, it also can be used as a foliar application for Japanese beetles and other pests. And again, you apply it earlier and it lasts a long time. It sits on the surface of the leaf. So this is what people have been promoting as much more friendly for Japanese beetle, both the adults and the grubs. Now, again, you can use Pyganic, which is an OMRI-approved pyrethrin, or you can use pyrethroids. A pyrethroid you could use for adults is called Onyx or bifenthrin. That formulation lasts a little longer, but again, it's going to kill bees. And 7-carbaryl is very harmful to bees. So acelepryn is what everybody, for both Japanese beetles on foliage and roots, is the choice nowadays. So preventative or rescue treatment, that is always a big issue. Most of our landscape services use preventative, and I'm not convinced they all have Japanese beetle problems. I think a lot of them have fungal problems. So then later in August they apply a second application, and a lot of these fungi come out in the spring in one form, they come out in the August when the turf gets more stressed from heat as another form, and I'm convinced a lot of the insecticide use on turf is misuse, that it really is the grass needs some kind of fungicide and not an insecticide. So if you need an insecticide, remember you always have to look for the grubs in the soil in the green area, but sometimes you need a rescue treatment. So my suggestion is to use the prophylactic or preventative treatment in areas where you have Japanese beetle problems. Use acelepryn, that's the professional product, or use GrubX, that's available to consumers. Both work really well. And then in August, if you still have damage and you still have a problem in the grass, I'm going to suggest you try microorganisms, and we're going to talk about that in a minute here. So this is where damage is the worst. In late summer, when the grass roots are fed on and the grass starts, the blades are getting heated up, and the roots are stressed because they've lost surface area, their root hairs were killed. And when you have Japanese beetle, you can just pull the turf back like that. It turns brown. So here are, again, our different chemicals for preventative grub control and rescue grub control. Acelepryn isn't recommended for rescue, but it is for preventative in the spring. You can use a neonic again, any of these, imidacloprid, clothianidin, thimethoxam, but again, if you have clover flowering, it's going to affect bees. So the new product out there is this product called GrubGone. It's Bacillus thuringiensis galleria. It's a new product. It works really well against Japanese beetle and all the white grubs. It's friendly to bees. So if you're doing landscaping for somebody who's worried about bees or for a park, you could use in the spring acelepryn, either the professional or consumer formulation, and then if you still get a grub problem, you could try either this soil pathogen that you add, or you can try nematodes as well, parasitic nematodes. So when grubs get really big in September, it is really hard to control them. Dilox is something we've had forever in Minnesota. Trichloroflan is the active ingredient. The problem is it's not good in alkaline waters. It doesn't have efficacy, and I don't know how many people use it anymore, but I'm not going to suggest it as a rescue treatment. Arena clothianidin can be used as a rescue treatment, but again, it's going to get into the nectar and pollen of clovers. So it might be better to try to use something like Grub Begone, this Bacillus thuringiensis galleria, or to try to use nematodes. Now, these nematodes, you apply them and then you water them in, and I've done research, and they work just as well as an application of Tall Star on Japanese beetle grubs. They work just as well. They just take a little longer. So now we're into the part of the talk. We're about three-quarters done here. And I want to talk to you about biocontrol. So what we always want to do with IPM, especially with exotics that increase in population size, is we want to try a way to change how their population is managed in the wild. We want to increase the amount of control by good bugs so that we can decrease pesticide use. So these first two, Typhia wasps and Isochetta flies, they have been introduced by the Department of Ag. They did not establish well. Where I come from in Maryland, you can see these Typhia wasps flying over the turf at night looking for white grubs. But in Minnesota, they did not establish very well, so that's not a choice. The next one is this protozoan that lives in the soil that Dr. Andreatis at the Connecticut Ag Station came across, and this is Ovicicula. And there has been a program in Michigan where they've released them on golf courses, and by 5 years they get quite a bit of control. And we're going to talk about that in a little more detail. Here's this grub begone, Bacillus thuringiensis galleria. Bacillus populi, the next one down, it's been given a new name, Pan bacillus, but it's the same organism. It doesn't work anymore. They think it worked in the 50s because the solution was contaminated with another bacteria. And then when they got better fingerprinting for detecting organisms, better DNA, they realized that they had a second organism in there that wasn't EPA approved. And so when they made the fermentation vat specific to Bacillus populi, it doesn't work anymore when you apply it. And everybody agrees on that. So if it says Japidemic doom, then just look, Bacillus populi is not what you want. You want Bacillus thuringiensis galleria to get grub begone. There's fungi out there, Bavarian metarhizium, you can apply, and these are especially good for irrigated turf. And then also these parasitic nematodes are very easy. You buy them as a sponge, or they're formulated with powdered milk. You just put them in a backpack sprayer and spray them out, and they really do a good job. This is just some research I did early on with these nematodes, and there on the left you see an elm leaf beetle pupae killed. Just sprayed it on the nematodes on the elm leaf beetles when they're lying on the surface under the elm tree. So that's a good choice. Befaria bassiana is a good choice for nurseries and greenhouses that have a lot of irrigation. It is commonly used now even for thrips control on foliage. It works really well. It's a generalist fungi. The spores touch the insect and they actually grow through the cuticle and then take over the whole body. And even if the insect doesn't die for them, they're enough of a challenge for the insect that they have a sublethal effect and the insect slowly dies. And you can tell you have Bavaria infections because the insect will get white. It's good for adults and larvae, and it's coming back for use in greenhouse because it works against thrips. I always like to talk a little bit about organic control. Some people in nursery greenhouse want to say that they do organic management, or landscapers want to advertise their services, and I'm all for this. But I just want you to realize that to be properly termed organic, it has to be on this OMRI materials list. And there are many products nowadays for landscapes and greenhouse that are organic. I mean, all this hoop house production nowadays is the A&E, the Turf and Ornamental Pesticide label, and so there's a lot more products now labeled for greenhouse hoop houses that are organic approved. And so OMRI is a list of products that are approved by the organic unions, and this is just in some examples: BT, Bacillus thuringiensis, Bavaria bassiana, which we've talked about, boric acid, Cydia pamela granulosus, it's a virus, of moss that gets on apples, diatomaceous earth, garlic, kaolin clay, limonene, which is orange peel, neem oil is the water-soluble form of azadirachtin. Azadirachtin is from a tree, kills everything. Horticultural oils, pyrethrin, spinosad. Sometimes there's some pheromones. So what makes like spinosad is used in greenhouses and nursery under the label conserve. In organic use, it would be the label entrust. And the difference is for it to be an organically approved product, it has to be a natural product of a natural plant or a natural organism, and it can't be formulated in petroleum oil. It has to be formulated in food oils like soybean oils. Again, just want to give you some perspective. This BT I'm talking about is down in the middle, Galleria. It's on grubs and it's grub begone. There are others out there. So BT, the reason why it is a good insecticide to use is it doesn't kill bees or non-targets because you have to ingest it, and then the protein crystal actually puts a hole in the gut. That's the mode of action of how it kills. And there are a lot available out there, and a lot of different kinds. So we would call these, it's not the genus and species, but it's a different type of BT. There's Christaki for moth larvae, Azawai for moth, Tenebrianus, which they use for Colorado potato beetle. But the one I'm talking about is grubgone, Bacillus thuringiensis galleria. Remember, bifenthrin is tall star. It's not organic, but it does come in ready-to-use homeowner products. Chlorothalonil nitropol is the active ingredient in acelepryn. It's not organic, but that's what I'm asking you to switch to. Acelepryn is either in GrubX or it is in a professional product, but the active ingredient is called chlorothalonil nitropol, which is a little harder to pronounce than GrubX. So just wanted to make you aware there's a lot of different BTs out there, but remember Bacillus populi is not Bacillus thuringiensis, its species name is populi. That's not working anymore. So azadirachtin is available as a homeowner product, a professional product, an organic product. It's from a tree. It's really good on aphids and caterpillars. It biodegrades in the sun, but it is very toxic. It does kill everything when you use it. It would kill a bee. And then there's neem oil, which says the hydrophobic extract of neem. There's very little neem in it. It's neem or azadirachtin in it. It suffocates the insect by coating them. It can kill beneficials, but it's considered a little better, a little more bee-friendly. Then we have these dusts that can be used that they adhere to the squash, and they prevent, when the insect tries to feed on it, it's very scratchy, and it scratches holes in their cuticle, and they dry out in the sun. Remember, pyrethroids, pyrethrins, and pyrethrum are pyrethrins. INS is the active ingredient. Pyrethrum is the name of the compound. It's from a daisy. They require piperonal butoxide. So pyganic, we found out, works really well for Japanese beetle. It is organic, but it's this piperonal butoxide that is a synergist that's making it work better. So right now I'm trying to go through the different products for the larval stage, the grub stage in the soil, and the adult stage. Oils and soaps are still out there, but they don't work well against Japanese beetle adults, and they don't penetrate the soil. Just want to talk a little bit here about the use of Japanese beetle traps. As you know, they call in the Japanese beetles, and so you get more than you want. A lot of my growers that work in Christmas trees, they put the grubs over pools of water, and the beetles are attracted to the traps and fall in the water, and that's how they've been reducing Phylophaga, that native beetle and Japanese beetle, in Christmas tree plantations. So I have lots of pheromone traps if somebody wants to try some, and with water. You basically have a trap, and then you'd have to buy your own lure. They're about $6 for this lure in the center picture. And on the right-hand and left-hand side are two different kinds of traps. Another thing they've talked about with managing Japanese beetle is to retrofit the landscape with resistant plants, and not use the susceptible ones as much. I don't know in Minnesota, where we don't have as much species diversity of eastern places, if that is a good option. So just to let you know that there are some more resistant trees, especially on these managed landscapes like a business, a corporate headquarters, or some of these managed homeowner associations. It might be a good idea to, when you do work on the landscape, to start retrofit it with some resistant plants. So again, the biocontrol Typhia vernalis and Isochetta were released by the Minnesota Department of Ag. Here is Typhia vernalis. It's a wasp. You see a drawing in the top left. You see the adult laying on its side, and it lays its eggs. Those are little dark oblong areas on the grub. So that's where it lays its eggs, and they bore into the grub and kill it. Didn't work very well in Minnesota. In the Northeast, adults Typhia feed primarily on a lot of honeydew, and they also feed on nectar. It's known that you need this food to support the Typhia, and maybe that's why they can't establish here. Like I said, where I come from, Maryland, where there's more flowering plants in the landscape when Japanese beetle grubs are out feeding, you'd see the Typhia wasps, and they contribute to control. This is the Isochetta aldrichia. You see it up in the corner there. Looks like a housefly. It's another parasite found in Japan of Japanese beetle. The female deposits about 100 eggs on the thorax. Again, they need nectar, and they like to stay around water. And again, this didn't work in Minnesota. They didn't establish. So what we're looking at trying to get established in Minnesota is this protozoan, Ovicicula populi. It says Ovicicula populi and gregaria are abundant where Japanese beetle has been long established in Connecticut and New York, and they suppress populations. Ovicicula known to infect approximately 25% of all JB grubs in Connecticut, and it was only found at one location in Michigan. I sent samples in, and one place in Minnesota out of about 2,000 Japanese beetles we found an ovicicula, and that was in the Stillwater in Stillwater in a golf course. The rest of the 5 locations around the Twin Cities did not have ovicicular. So there's another parasite called Stictospora, but ovicicula is what people have been releasing now in Michigan. They've released them in Kansas, and they are creating epizootics, which means they get established and are persistent. And like I said, after 5 years in Michigan and Kansas, the golf courses have gotten about 70% of control. So we're going to try to, some people and I at the U are going to try to get grant money, and we're going to see about introducing ovicicular and seeing if we can get it established here and help knock down the grub populations in the spring, which is, from our beginning of the talk, is what's leading to this outbreak in populations, that our winters are ending earlier, the springs are warmer, and when the grubs come up to feed, they have limited fat, but when it's warmer, they're not being killed. So that's the contributor to making them so abundant. You saw Typhia and Typhia vernalis lays eggs on the grubs. You saw Isochetta lays eggs on the adults, and they don't work very well in Minnesota. The preventative treatment is acelepryn. Can't be used as a rescue treatment, so if you have a huge problem, you probably need to use a neonicotinoid in September, up till September, from mid-August to mid-September. But again, the take-home message is this new Dow product called acelepryn is what you want to use on grubs in the soil or adults on foliage. And we're also, in this grant, we're going to try to look at traps, putting that grub begone, that Bacillus thuringiensis galleria in the traps, attracting the adults and then letting them leave the traps as a way to spread that bacteria around. So between spreading the bacteria, the Bacillus thuringiensis galleria with traps, And with introducing more ovissicular in Minnesota, we're hoping to kill more grubs and not end up with the adult population issues we have. So in summary, if you have grub problems, try acelepryn in the spring. You have to use it as a preventative. If you get grub problems in the summer months, you could use, rather than a neonicotinoid, which is going to be sequestered in any flowering plants in the turf, you could try the grub gone, the new bacillus species, or you could try nematodes or Bavaria. If that's not to your liking, you could try a neonic in the soil, but then be aware this has a high propensity to hurt bees. So I've kind of used up my time here to the minute, and I'm really interested in hearing your issues and helping me out. So please ask some questions, and thanks so much for listening over lunch, and we have a couple more of these planned, so please come back.
Great, thank you. And just audience members, just a reminder, if you would like to ask a question today, you can click on the Q&A tab on the top side of the screen and then select Ask New Question. Don't forget to hit the Submit button after you've asked your question. Dr. Krishnik, we had a question here. It says, are there any options for protecting roses from the beetles without harming the beneficial insects, especially bees?
Yeah, so that acelepryn is what I would try. Once it's dry, it doesn't harm the bees. And, you know, the big issue is Japanese beetles feed on tea rose flowers, and especially the shrub rose that's on the flowers. And so you don't want a systemic that's going to get absorbed. You don't want a neonic. You never want to spray that on a flower. But this acelepryn is a good product, so I would try that. If I had roses or was managing the rose garden over on Lake Harriet, that's what I would try.
Great, thank you. And our next question here says, why is a Japanese beetle a worse pest than native grubs?
Well, the issue is that they arrive without their natural enemies. So this is a continuous problem. So when we get an exotic insect from someplace else, it comes without its natural enemies. And so in that category are gypsy moth, emerald ash borer, all sorts of different pests who arrive without their natural enemies. So by using that grub gone bacteria in the soil and by establishing ovissicular in states, we're going to start to restore the balance of nature. But I do find it so funny that the Kyoto Press contacted me last year and gave an interview because there are no Japanese beetles in Japan. So that's pretty funny.
Great, and I just want to remind everybody again to ask a question today. You can click on the Q&A tab on the top side of the screen and then select Ask New Question. We had somebody asking about handouts for today. I'd just like to remind everybody that the handouts and more additional information can be found on the left side in the announcements section. There's a link there that says click here to visit Dr. Krishnik's website for more information. You can gather all materials there. Our next question here says, at what growing degree until would we expect to see our first generation of Japanese beetles?
Okay, so yeah, I can't tell you the degree day, but it is usually the July 4th weekend you see the first adults. And there is only one generation in Minnesota, so you're going to see the adults. They're out to mid-September laying eggs, 60 to 100 eggs per female, and then they stay in the soil till the next July 4th the next year and come out. So that is usually, in my experience, 15 years of trapping when I see them, and that's the MDA experience as well.
Great, thank you. Our next one here says, are we going to see any reduction in the grub population due to the prolonged cold weather this winter?
Yeah, so now doesn't matter. I mean, it matters to me and you, but the insects are happy in the soil. They're protected. So it's really that May-June interface. And, some years we don't get leaves on trees until, after Memorial Day. Remember years ago? And now by Memorial Day there's leaves on the tree. So that's the issue. It's the warming up in mid-April that is allowing all these grubs to survive. So I don't think this winter is going to help unless it's really cold in April and May.
Great, thank you. Our next question here says, is acelepryn available in granular form or liquid?
That's a good question. I haven't used it myself. I'm pretty sure it's a liquid, though, because you also spray it on foliage. So I don't know if a granular is available yet, but having said that, the product Grub X is a granular. So the homeowner product is a granular. The professional product right now is a liquid. But, as something like this that works so well and there's such a demand, I'm sure there's going to be different formulations. So I'm sure a granular for professionals will come about.
Thank you. And just a reminder again for our audience members, if you'd like to ask the question, go ahead and click on the Q&A tab there on the top left side and then select Ask New Question. Our next one here says, if you're managing a new lawn or area and do not have knowledge of its history, would you recommend that you be proactive and go ahead and do a preventative, or should you wait?
So I would say wait, and the reason why is if it's a new lawn and it's newly seeded, you're not going to have any grubs. That's pretty sure. If you seed it in the spring, you're not going to have any grubs. If you use turf, you install the turf landscape, usually the grubs don't come with the turf because by the time it's been taken up and wrapped, it's out of the time when a female would lay eggs in them. So they usually accrue after the new lawn is established. And the issue would be if you can slow down irrigation in mid-season in July and August. If your lawn goes dormant, then you don't get Japanese beetles. The females want to lay eggs in soft grass, soft humus, because they have to dig down there to lay their eggs. So they're attracted to bright green turf. So if the turf is watered less in July and August, that would be the cultural control to reduce Japanese beetle oviposition, females laying their eggs. So that's what I would do with a new lawn. I'd get it established and vigorous and then slow down the watering in July and August. And then in September, females are pretty much gone by September. You can then water it to get the roots ready for the winter.
Great. And our next question here says, what controls Japanese beetles?
What controls the adults? Really nothing. The birds will eat them. Sometimes I've seen phoebes and birds, but now that we're having this huge songbird decline. So the adults, nothing's getting them. The grub stage, it's that protozoan in the soil oversicular or the nematodes or the grub-gone bacillus. So it would be soil pathogens for the grubs, and we need to get those established here in Minnesota.
Great, and just want to remind anybody, if you do have a final question you'd like to ask before we wrap up today, please make sure you get that question in. Don't forget to hit the submit button. Our next question here says, you mentioned that August and September are the best time to treat grubs. Do you recommend the acelepryn at the time or the BTG?
Yeah, so that's a really good question. From what everybody has told me, the acelepryn needs to be used in June because it needs to sit there and get absorbed by the roots. Evidently, it's not as water-soluble as like a neonic. But it should be a preventative for you. So you should use it in places that you've managed that you know you have Japanese beetle problems. If you then need a rescue treatment, I would use the pathogen in June, or if you have to, a neonic.
Great, thank you. And our next question here says, what insecticides are bee-friendly?
Well, when you go to if you can go to my website, I will post this talk as a PDF on my website. You have to give me an hour. There is something called updated pesticide toxicity to bees, and it tells you exactly what chemicals are toxic to bees. It was approved by all the big chemical companies. So, unfortunately, insecticides kill insects, and bees are insects. The problem with these neonics is that bees are very sensitive, more sensitive than other insects to them. And the neonics were actually registered as a biorational pesticide because when they first registered it, they didn't know they the neonics got into pollen and nectar. And it's very friendly to humans. It's very low toxicity to humans. But unfortunately, we don't have the receptors bees have, and so they're very toxic to bees. So to answer the question, I would use this in an area where I have to do preventative, where I know I have grub problems, where it's heavily irrigated, heavily fertilized, because that's the look people want. Use the Celiprin. I would wait for rescue treatment to see if I had grubs, and then in July, August, I would try these different soil pathogens. But remember, you can always try a neonic, but you're going to have an impact on bees.
Great. We have time here, I think, for one more question. It says, is the acetaphane a good product to soil or trunk inject on birch and linden trees a week or two prior to July 4th?
So that's a really good question. Acephate does get systemic. Orthene is systemic. I would rather see a trunk injection. My data says that when you throw something on the soil surface, it gets into volunteer plants at high levels. So I'm becoming more and more an advocate for trunk injections or trunk drenches with Dinotefuran safari. So it's going to work. I do not know how much acephate is going to get into the flowers the next year. I have never seen any research on that. Even can it? So I'm going to say we can't answer that, but I think the short answer, it's better to inject birch or linden trees. As you said in this question, it's better to inject them after both of those have stopped flowering and making their catkins. And I would try acephate. I've never seen any data on if it gets into pollen and nectar or into the catkins of birch.
Great, so that does look like all the time that we have for today. So I'd like to thank Dr. Krischik for her excellent presentation today, and on behalf of MLA, I'd like to thank all of you for your excellent questions and your participation. Audience members, at this time, you should now see a survey live on your screen. If you could please take a moment to fill out this survey. Any answers that you give are greatly appreciated, as MLA does use these to help improve for future webinars. Once again, thank you for joining us today. This does conclude today's program, and to disconnect, you may simply hang up or exit out of your browser window.